Dear viewers and listeners, welcome to lesson number 2 on the subject of economics. In this lesson, I will discuss and explain the concept of price elasticity of demand, also called PED, with examples and illustrations. So watch the full video carefully for a better understanding of this vital economic concept. Price elasticity of demand explains the relationship between quantity demanded and price. It shows the responsiveness of demand to changes in price. The coefficient of price elasticity of demand, called PED, is calculated by the formula percentage change in quantity demanded divided by percentage change in price. This formula can be applied either over a range of prices or at one point, that is called point elasticity, or over the whole curve, that is called arc elasticity. The coefficient of elasticity calculation for normal goods gives a negative result because price and quantity demanded are inversely related. However, for inferior goods and those with unusual shaped demand curves, the elasticity will be positive, showing an increase in quantity demanded when price rises. A summary of price elasticity is shown in this table. As you can see from the table that for perfectly inelastic goods and services, the PED value is 0, implying that demand for such goods and services does not react to changes in prices. From a practical perspective, it may be said that goods with 0 PED value may not exist. Relatively inelastic goods and services have PED values falling between 0 and 1, and this list may include most goods and services that may be considered as necessities of life. The unit elasticity may refer to a situation where changes in price lead to an equally proportionally change in demand. In simple words, if price rises by 10%, demand will fall by 10%. Again, this may be a rare situation in real life. Relatively elastic goods have a PED value between 1 and infinity. Examples may include luxury goods like TVs and designer brands. Typically, a good or service is said to have high price elasticity when many substitutes for that good exist. In case of perfectly elastic demand, the PED value is infinity, implying that it is a theoretical concept with no real-life example. The slope and position of the demand curve will determine the actual numerical value of the elasticity. Generally, if the demand curve is fairly steep, a large change in price will cause only a relatively small change in demand, indicating an inelastic demand curve. It is often wrongly assumed that the two demand curves with the same shape will have the same elasticity coefficient. The coefficients for the same range of D1 and D2 in the figure are calculated for a price fall, that is triangle C. For D, that is triangle C, the quantity demanded increases from 5 to 10, that is plus 5, as the price falls from 10 to 5, that is minus 1 over 2. Elasticity is therefore calculated as 5 over 5 divided by minus 1 over 2, that is minus 2. In contrast, D2 within triangle C shows that quantity demanded increased from 15 to 20, that is plus 1 over 3. When the price fell from 10 to 5, that is minus 1 over 2. Elasticity is therefore calculated as 1 over 3 divided by minus 1 over 2, and this will give us minus 2 over 3. This demonstrates the importance of the position of the demand curve. Generally, a curve further from the origin will tend to be less elastic, as shown in the diagram. The numerical value of the elasticity coefficient also varies according to 1, whether a price fall or price rise is calculated. In this figure, D2 elasticity is calculated as minus 2 over 3 when price fell from 10 cent to 5 cent. However, a price rise of 5 cent to 10 cent gives an elasticity of minus 1 over 4, that is minus 1 over 4 divided by 1. This occurs because elasticity shows relative percentage changes and the base from which the calculations are made differs. 2. Which part of the demand curve is selected? Elasticity varies from point to point on a straight line demand curve, but not on a rectangular hyperbola. As a calculation moves down a linear curve from top left to bottom right, the elasticity value falls. That is, the curve becomes relatively more inelastic. In this figure, the price elasticity of demand for a price fall on D2 at point A is minus 4, that is 1 divided by minus 1 over 4, whereas at point B it is minus 3 over 2, that is 1 over 2 divided by minus 1 over 3. And at point C, this is minus 2 over 3, that is minus 1 over 3 divided by 1 over 2. The elasticity can also be calculated by examining total revenue. This method is most useful to businessmen. If total revenue increases following a price cut, then demand is elastic. However, if total revenue increases following a price rise, then demand is inelastic. Conversely, if total revenue falls after a price cut, then the demand is inelastic, and after a price rise, it is elastic. If total revenue remains unchanged, then the demand is of a unitary elasticity. There are several factors which determine the price elasticity of demand. Number one is income. Where a good constitutes a small proportion of consumers' income spent, then a small price change will be unlikely to have much impact. Therefore, the demand for unimportant items such as shoe polish, matches, and pencils is likely to be very inelastic. 2. Substitutes. If there are close and available substitutes for a product, then an increase in its price is likely to cause a much greater fall in the quantity demanded as consumers buy suitable alternatives. Thus, the demand for a specific variety box of chocolates may be fairly elastic because there are many competing brands in the market. 3. Necessities. The demand for vital goods such as sugar, milk, and bread tends to be stable and inelastic. Conversely, luxury items such as foreign skiing holidays are likely to be fairly elastic in demand. Habit. When goods are purchased automatically without customers perhaps being fully aware of their price, for example newspapers, the demand is inelastic. Time. In the short run, consumers may be ignorant of possible alternative goods in many markets, so they may continue to buy certain goods when their prices rise. Such inelasticity may be lessened in the long run as consumers acquire greater knowledge of markets. Definition of market. If a market is defined widely, for example food, there are likely to be fewer alternatives and so demand will tend to be inelastic. In contrast, if a market is specified narrowly, for example orange drinks, there will probably be many brands available, thereby creating elasticity in the demand for these brands. If you have liked this video, please do subscribe to my channel and also share and like this video. Thank you for watching.